All right, in today's lesson, we're going to look at special quadrilaterals. Remember, these are four-sided figures. And again, this is just some basic introductory material. Obviously, if you need to pause or whatever while you're taking notes, make sure that you do those things. Because I will ask you to draw some of these figures, quizzes, tests, things of that nature. So make sure that you are paying attention to markings that I have on these figures. Because if I ask you to draw these, I expect you to have these markings as well. All right, the first figure that we'll talk about is a trapezoid. And a trapezoid is a quadrilateral with exactly one pair of parallel sides. That's it. It can only have one pair. If it has more than one pair, then it's no longer a trapezoid, and we'll talk about what that figure is shortly. Okay, so there's an example of our trapezoid. Now, another type of trapezoid that really kind of confuses some people, let me go ahead and draw that for you here. And again, I'm not real sure why, but it does tend to confuse a lot of people, so let me show that. So for example, I could draw that figure there, and that would be an example of a trapezoid, which normally we do okay on. However, when I do this, let's group those figures so I can rotate the whole thing. When I rotate the whole thing and it looks like this, with these being right angles down here, that tends to confuse a lot of people with it being a trapezoid. Trapezoid can have anything for the angles. That doesn't matter. But it has to have the parallel sides, which would be these two sides right here. Now, in order for something to be parallel, you need to see these little arrows. If you don't see these arrows, and I don't tell you in the directions that, maybe that lines that appear parallel are parallel, then they're not parallel. You have to see these markings for them to be parallel. A kite is a special type of quadrilateral. It has two distinct pairs of consecutive congruent sides. So for example, let me scroll down here a little bit. So for example, for this kite, I would have these two sides as being congruent with the two tick marks, and these two sides would be congruent with just the one tick mark. Now, we're going to go more into depth in kites a little bit later on, but for right now, all you really need to know about a kite is that it has two sets of congruent consecutive sides. So they have to be next to each other. All right, next is a parallelogram. In a parallelogram, it's any quadrilateral with two pairs of parallel sides. Now, there are a lot of figures that fall into this parallelogram category. A trapezoid and a kite are not parallelograms. Okay, so kind of keep that in mind. All right, so parallelogram, I've got two pairs of parallel sides. So for example, on this figure, I've got two pairs. There's one and there's one. And on this figure, which this is the way that you kind of, I guess, more traditionally see a parallelogram drawn, would kind of look more like this second figure here. Now on this first one, it looks like a rectangle, but you don't know anything about the angles, so it's strictly just a parallelogram. Okay, and then this figure, obviously, it doesn't have right angles. You can tell just by looking at it. But again, this is probably the more traditional way that you see a parallelogram. All right, a rhombus. A rhombus is an equilateral parallelogram. Now notice it's just equilateral. We talked about this yesterday in class, that polygons do not have to be both equilateral and equiangular. They can be one or the other. And our rhombus is an example of that. It's got four congruent sides, so it's equilateral, but it does not have congruent angles. Okay, so those would be the markings if I ask you to draw a rhombus. You should have the parallel sides and the congruent sides. A rectangle is very similar to a rhombus, except that it's a parallelogram with four right angles. Another way we could write that, we could say that it was an equiangular. Oops, only one U there. And I'm having a hard time here. Here we go. Equiangular parallelogram. Okay, so that's another way you can think of it. It's an equiangular parallelogram. And the other thing with a rectangle, not only are the opposite sides parallel, but the opposite sides are also congruent. And that should make sense, because if the angles are all congruent in a parallelogram or any kind of quadrilateral, then they have to be right angles. So we know that in a rectangle. Okay, so that would be a rectangle. A square, it's an equilateral rectangle, an equal angular rhombus, or a regular quadrilateral or regular polygon. We could say either one. So it actually fills multiple categories with a square. Okay, so a square is a rectangle, but a rectangle is not a square. So I've got 4 congruent sides, which makes it equilateral. I've got congruent angles. And since it's a polygon or a quadrilateral with 4 congruent angles, they all have to be 90 because the degree measure of a quadrilateral is 360. And it also has to have parallel sides, 2 sets of parallel sides. Okay. Now, one thing, notice we haven't talked a lot about the diagonals, anything like that, and we're not going to yet. We will get much more in depth into that a little bit later on in the year because the diagonals do have special properties in these figures. That's more of a second semester topic. All right, so an example I'd like you to work on, and we'll talk about this in class. I want you to draw a rectangle ABCD. I want you to draw the diagonals in BD and AC, and I want you to intersect it at point E. Make sure that you label the figure correctly. Use all the proper markings, the parallel symbols, the congruent symbols, all those types of things, because you will have to do that, like I said, on your tests over this unit. So start getting into that habit now. And I'll call a volunteer up at the beginning of class tomorrow to see how well you did those things. All right, another example that I would like for you to work on tonight, and we will talk about it tomorrow, is very similar to the example that we did with the triangle in class today. So we have 2 congruent kites. Okay, these are going to be congruent kites. One is kite ABCD, and you have that in your figure there. The other is LMNO. And what I want you to do tonight is to think about where the points N and O have to go in order for these 2 figures to be congruent. Now, it doesn't have to only stay on this coordinate grid that we gave you there, because there's actually 2 possible options, and I'll accept either one. You could keep it on the grid, or it could end up off the grid. So I'll accept either answer. But like I said, there's multiple ways to do this. I believe there's probably 4 correct answers. So see if you can find those 4 answers, and we will talk about those tomorrow in class after we get done with the warm-up. And that's it for today.